Marihan College of Education. My name is Trishna Parmar and our today's subject is Maths, Standard 7. So before we begin with our today's topic, let us check how much you have learned from your previous class. So define prime factors. What are prime factors? A factor that is divisible only by 1 or by itself. Examples are 2, 3, 5, 7, 9, 11, sorry, not 9, 7, 11, 13. These are all the prime factors, correct? Now, rule by Euclid is used to find the GCD or HCF and LCM of numbers. Now, what does the rule say? Any composite number can be written as the product of their prime factors or prime numbers. Now you have learned this horizontal arrangement for HCF, correct? Now let us solve one. They have given two numbers 60 and 70. They have solved it in horizontal manner, taken what is common in both the numbers, correct? We only take the common factors. So 2 into 2 into 3, which is 12. So 12 is the HCF, highest common factor of 60 and 72. Now we'll see the vertical arrangement. Now HCF of 850 and 680. Now this is the two methods, horizontal arrangement and vertical arrangement. So vertical arrangement, we solved it in this way, vertically. Now the HCF of 850 and 680 is 170 meters. Okay, this is the highest common factor. So we have taken this, and 2 and 5 are common. So 17 is common, 2 and 5 are common, and that is how we get 170 meters. Prime factor method. So you have solved this method just now, correct? The HCF of two or more numbers is the greatest number which divides each of the numbers without leaving behind any remainder. Now we find the HCF of 60, 12, 36 in the vertical arrangement. If you see in this, we have solved this in a vertical arrangement, 60, 12, 36. Now common is 2, 3. Okay, so 2 into 2 into 3, which is equals to 12. If you observe carefully, 12 is one of the given numbers. So if one of the given number is the HCF, then it becomes the divisor for other two numbers. Hence children, I hope you have understood till here how to find out the HCF and what are the prime factors. Okay? So today we will learn about the divisible method of finding HCF and LCM. So let us begin the division method of finding HCF. First we will see the theory and then we will solve some problems. The division method for finding HCF. Find out the small number and divide the bigger number with smaller one. Now divide the previous divisor by the remainder in this division and repeat this same step till remainder is 0. Now I know this second statement is little confusing. Okay, HCF is the divisor in which remainder is 0. Now we will see with the example.
Hello children, so we just now saw the steps of the division method for finding the HCF. Now let us solve an example. Find HCF of 144 and 252. So which is the smaller number? 144, and which is the bigger number? 252. So let us now divide. 252 and 144. So 252 divided by 144. So we need to check which is the smaller number so we can minus this. So 144 into 1 is 144. 144 into 2 is 2 2s are 2 4s are 8. 2 4s are 8 and 2 1s are 2. 288. So the second multiple is only 288, right? So we will only multiply by 1. So 144 into 1 is 144. So our remainder over here is 801. Now if you observe the second step, it says divide the previous divisor by the remainder in this division. So we have done the first division. Now in the second division, we have to divide the divisor with the remainder. So 108 and 144. So 144 divided by 108. So 108 we have to minus 144. So 108 into 1 is 108. 108 into 2 is 2 8s are 16. 2 zeros are 0, 1. 2 1s are 2. So the number is bigger. So we will just again do 108 into 1 is 108. Now I have already solved this, children. So the remainder comes as 36. We have to divide till the time the remainder is not 0. So now the remainder is 36. Again follow the same process. 108 will come as a divisor. Okay. 36. 108 divided by 36. Now 36 into 3. If you see in 3 table, 3 6 are 18. 8 and 1. 3 3s are 9. Plus 1 is 10. So 108. So here comes 0. We got a 0. And the number with which we divided becomes our HCF. So HCF of 144 and 252 is 36. This is the process of the division method for finding the HCF. Okay, children? Now let us see how to reduce 209 divided by 247 to its simplest form. We again have to do this division method for 209 divided by 247. Let us see that first now. I rub this line. Reduce to its simplest form. Okay, children? The question is 209 divided by divided by 247. Now first we will check which is the bigger number and which is the smaller number. So 247 is the bigger number and 209 is a smaller number. So remember our first step, divide the bigger number with the smaller number. So now we will divide. 247 divided by 209. So 247 divided by 209. So this is the bigger number. So 209 into 1 is 209. So with this we get as answer as 38. We have to repeat the same step till the time we do not get the remainder as 0. So 38. So 209 will become the divisor and 38. Now sorry, 209 will become the dividend and 38 will become the divisor. So 38 into 5. What is 38 into 5? It is 190. So if we divide 190, we get as, what we get? 19. Correct, children. Now we have a remainder again, so we will divide. So 19 and 38. So 19 into 2 is 38. 2 nines are 18, 2 ones are 2, carry 1 is a plus 1. So 2 ones are 2 plus 1 is 3. So we get our answer as 38. So our HCF of 209 divided by 247 is 19. Okay children, this is how you divide. Now we will turn this into the simplest form. We have the HCF. So what is the HCF? HCF is 19. I'll erase this. Okay children? So we have to reduce this to its simplest form. So 209 divided by 247 is equals to 209 divided by 19 upon 247 divided by 19. Okay, this is how you will convert this into its simplest form. Okay, now if we divide this, we will get answer as 11 upon 30. This sum is already given. If you divide this number with this, the answer will be 11 upon 30. Okay children, so this is how you have to reduce the HCF with the help of the HCF. Okay, when the given number is given and then they say reduce to its simplest form. So you have to find out first the HCF of this number. Then after finding the HCF, you have to reduce it to its simplest form. So you just have to divide this two together and then you will get your answer in the simplest form. I hope you children are understanding how to solve these sums. Now children, we are going to solve the practice set 12. The first is find the HCF. Okay. So let us take the first question, which is 25 and 40. Okay. Now we'll divide it differently, but in a vertical manner. 25 and 40. So we know 25 comes in 5 table. 5 5s are 25 and 5 1s are 5. Over here we have 40. So we also know that 40 comes in the 5 table and we can also write it in the 2 table. So 2 2s are 4, 0. 2 1s are 2, 0. 2 5s are 10 and 5 1s are 5. So 25 has 5 into 5. 25 has 5 into 5 and 40 has 9 factors as 2 into 2 into 2 into 5. So the common number is 5 in both of us, correct? Therefore, the HCF is 5. So the HCF for 25 and 40 is 5. Now we will solve the second sum. Find the HCF of 56 and 32. Two separate lines, 56 and 32. Okay? So 56. So 56 comes in which table, children? Come on, tell me, 56 comes in which table? Other than that, we'll do simple multiplication. Okay? 2 2s are 4. Carry 1. 2 8s are 16. Then 2 1s are 2. 2 4s are 8. 2 7s are 14 and 7 1s are 7. In 32, we will again do the same, okay? 2 1s are 2, carry 1, 2 6s are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. We all know till the time we do not get 1, we will keep on multiplying. Right? Now, 56, we have the prime factors as 2 into 2 into 2 into 7. And in 32, we have the prime factors as 2 into 2 into 2 into 2. 1, 2, 3, 4. 1, 2, 3, 4 and 1 remaining is 5. So in HCF, we only take the common factors, right? So common factors will be 1, 2 and 3. So HCF of 56 and 32 is equals to 2 into 2 into 2, which is equal to 2 2s are 4, 4 2s are 8. Okay, children? We have solved the first and the second question. So the HCF of 56 and 32 is 8. HCF of 25 and 40 is 5. I'll erase this all, okay?
Welcome back, children. I hope you understood the division method for finding the HCF. We also solved some problems on HCF, correct? Now, when we were solving the division method, that time we divided the number till the time we did not get the remainder as 0, correct? We never stopped trying. So children, problem solving is important. We tried to solve this problem till the time we did not get a desired output out of it, correct? Till the time we did not get the remainder as 0 because we wanted our HCF. In the same way, we should never stop finding solutions to your problems. So always keep solving your problems until the time you don't find the solution. Keep on trying. Okay? Now we will move to a new topic, that is LCM, least common multiple. Now LCM of the given number is the smallest number that is divisible by each of the given number. Now there is a difference in LCM and HCF. In HCM we only used to take the common factors, correct? But in LCM we take the common factors, but we also take the factors which are not common. So let us see with an help of an example. Find LCM of 60 and 40. You have then horizontal method and a vertical method both. In LCM, we use both these methods also. Okay, so horizontal method. 60 is 2 into 2 into 3 into 5. If you solve this, you get the number as 60. And 48, 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 to 3s are 48. Therefore, LCM is, if you observe, there is 1, 2. 2 common, we have taken this. Over here, 2 common, we have taken this. Now, 3 is common, we have taken 3. Now, this 2 and this 5 is still remaining, correct? So we have taken also the remaining factors. So we take the common factors and we take the remaining factors also. And this is how we get our LCM, which is 240. This is horizontal method. Now vertical method. This is the same output which we are going to receive. But this is how you are going to solve it. You can even solve this by 5 ones are 5 and bring out 2 and 2 ones are 2. And all the numbers will come over here. So children, this will be the same output. Therefore, LCM of this and this is 240. So you take all the factors, common and which are not even common. To understand LCM, that is the least common multiple, more nicely, we will go ahead and solve some problems based on LCM. So let us start.
Hello everyone. You have just read the concept of LCM, least common multiple. Now we will solve few problems on it. LCM. We have already solved the problem which is 60 and 48. Now we will solve 16, 28 and 40. 16, 28 and 40. So 16, 28, 40. Now let us solve. 2 8s are 16, 2 1s are 2, 2 4s are 8. 2 4s are 8, 0 down. 2 4s are 8, 2 7s are 14 and 2 1s are 2, 0 down. 2 2s are 4, 7 just like that and 5. So now this and this can only divide by itself, correct? So we'll just keep them like that. Now we will go ahead and solve this. So LCM of 16, 28 and 40. So 16 is 2 into 2 into 2 into 2. So 2 into 2 into 2 into 2. 4 times 2. Correct? Now 28. 2 into 2 into 7. 2 into 2 into 7. And now 40. 2 into 2 into 2 and 5. Into 2 into 2 and 5. So children, the LCM of 16, 28 and 40. So 2 is the only common factor, correct? So we will write here 2. And in LCM, we write the factors which are not common also. So 2 into 2 into 2 into 2. 4 times. 1, 2, 3. And this one is the common factor. And now 7 and 5. So LCM of 16, 28 and 40 is 560. So if you multiply all this, the answer will be 560. This is how you take out or divide the three numbers together and find out the LCM. I'm erasing this, children. This is very simple. It's just like HCF, but you have to include the factors which are not common also. Now we will do one more sum. Okay? Find the LCM and HCF of 18 and 30. Over here they have told us to find the LCM and HCM both. So find LCM and HCF of 18 and 30. Okay, now first, before going ahead, we will solve the LCM and HCM. So, LCM and HCM of 18 and 30. So we know in 3 table 18 comes. 3 6 are 18, 3 1s are 3, 0 down. 2 3s are 6, 2 5s are 10. Now these are the numbers which are divisible by itself. So HCF of 18 and 30 is equals to 3 into 2, correct, and into 3, and 30 is 3 into 2 into 5. So what are the common factors? It is 3 and 2. So 3 into 2 is equals to 6. Okay, now LCM of 18 and 30. Now LCM will also be the same, 3 into 2 into 3 and 3 into 2 into 5. But over here we know that 3 and 2 are common, so 3 into 2 into, and we even take the numbers which are not common, 3 into 5, correct? So the LCM of 18 and 30 will be 3 into 2 6, 6 3s are 18, 18 5s are 90. So LCM of 18 and 30 is 90 and HCF of 18 and 30 is 6. Now let us come to the second part of the question example. Compare the product of the LCM and HCF with the product of the given numbers. Now we have to compare the product of HCF and LCM with the product of the given numbers, which is 18 and 30. So HCF into LCM should be equal to 18 into 30. That is the product of the given numbers. So HCF and LCM is 6 into 90, which is equals to 18 into 30. So 6 into 90 is 540. And 18 into 30 is also 540. Therefore, the product of given numbers is equal to the product of HCF and LCM. So children, remember this. The product of given numbers is equal to the product of HCF and LCM. So this is how you find out if HCM and LCM is equal to the product of the given numbers. You first have to find out the HCF and LCM of the given numbers, then multiply the given numbers and see what is the product. Then multiply the HCF and LCM together and see what is the product. So you need to find out if they are equal or not. Okay, and we have done that. So the product of given numbers is equal to the product of the HCF and LCM. Now we will solve one more sum. The product of two-digit numbers is 1280 and the GCD is 4. What is their LCM? Over here we need to find out what is the LCM. Okay, so they have given the product of two numbers, which is 1280. They have given us the GCD, that is, or HCF, which is 4. We have to find out the LCM. We have just solved one sum which says that HCF into LCM is equals to the product of given numbers. Correct? So HCF is 4, into LCM we have to find. We know the product, which is 1280. So simple. If it's a multiplication, if it goes on the right hand side, it becomes the division. So our LCM is equals to 320. 4 ones are 4, 4 threes are 12, 4 twos are 8, and 0. So this is how you find out the LCM. Hello children. Now we are going to solve the practice set 13. Okay. Now the first question is, find the LCM. In that, the first is 12 and 15 number. So let us find the LCM of 12 and the LCM of 15. 2 6s are 12, 2 3s are 6, 3 1s are 3. Then 3 5s are 15, 5 1s are 5. Very simple, correct? Now LCM is equals to, what is the LCM of 12? Now 2 into 2 into 3 and 15 is 3 into 5. Correct? 5. Now over here only number 3 is common. So LCM of 12 and 15 is equals to 3 into 2 into 2 into 5. So 3 into 2 is 6, 2 into 5 is 10. So the LCM of 12 and 15 is 60. Okay children? Now let us solve this second problem. The second is the three numbers 6, 8 and 10. Correct? Now we will solve this. 6, 8, 10. We can even do it together, correct? So 2 3s are 6 and 3 1s are 3. 2 4s are 8, 2 2s are 4, 2 1s are 2. 2 5s are 10, 5 1s are 5. Very simple. So LCM of 6 is equals to 2 into 3. 8 is equals to 2 into 2 into 2. And 10 is equals to 2 into 5. Therefore, LCM 1, 2, 3. 2 is common, so we have taken 2. Now we'll take the remainings. 2 into 2 into 3 into 5. So 2 2s are 4, 4 2s are 8. Sorry, 2 2s are 4, 4 2s are 8. And 8 into 15. What is 8 into 15, children? It is 120. So this is how we found out the LCM of 6, 8 and 10.
Welcome back, children. So we solved a lot of problems on LCM, correct? The least common multiple. I hope you all understood the problems because you need to solve more. So with this, we will move to our next topic, which is the uses of LCM and HCF. Now uses HCF. It helps us to equally distribute a set of items in the maximum number of groups possible. Okay. LCM. To split things into smaller sections. To equally distribute any number of sets of items into larger or into their largest grouping. To figure out how many people we can invite. And to arrange something into rows or groups. To see how these LCM and HCF is useful in our real life, we will watch a small video.
Today, we are going to solve some problems based on the uses of HCF and LCM. Now let us begin. I've already written the sum. So this is example number 1. Now let us read example number 1. A shop sells 450 gram of bottle of jam for 96 rupees and 600 gram, that is the bigger bottle, for 124 rupees. Now which bottle is profitable to buy? Over here, children, if you solve it from a unitary method, it is going to be very easy because you have already solved it. But now we are going to solve this with the help of HCF and LCM. Therefore, children, first we have to find the HCF and LCM of 450 and 600. I am going to do with it a shorter manner. So I know that 150 into 3 is 450 and 150 into 4 is 600. If you calculate this, it's going to be 450 and 600. So HCF is 150. So we are going to use a bigger HCF. So 450 grams of jam is equals to 150 into 3. If we divide 450 by 3, we get 150. Hence, we will say this as our equation 1. And if we divide 600 by 4, we will again get 150. Let us be our equation 2. Okay, children? So this is 150 grams of jam bottle. Now, in the smaller bottle, we know that 450 gram cost is 96 rupees. Now we will find out how much this 150 gram of bottle cost is in the small bottle. So we know 96, therefore 96 rupees is for the smaller bottle. So 96 upon 3 equals to 150. If we solve this, 3 ones are 3, 3 threes are 9, 3 twos are 6, correct? So it becomes 32. So 150 gram of bottle is for 32 rupees. Now we will see for the equation 2. This was equation 1. Now we will see equation 2. Equation 2 is 600 gram of bottle cost is 124 rupees. So we will write 124 divided by 4 equals to 150 gram. Okay. Now 4 ones are 4, 4 threes are 12 and 4 ones are 4. Therefore, the 600 gram of bottle cost 124 rupees. But in the same way, 150 gram of bottle, in the bigger bottle, it cost us 31 rupees. So, the benefit of buying 600 gram of bottle is more than the smaller bottle. Correct? we save 1 rupees for each 150 grams. Therefore, the profitable is the bigger bottle. The profit is to buy the bigger bottle. I hope you understood this equation. We have just put the equation 1 and added the amount. We wanted to know how much 150 gram of bottle in a smaller cost is, and in the larger bottle how much 150 gram cost is. So that is very true. 31 rupees is much lesser and it is profitable for us to buy. So we will always go for 600 gram of jam bottle. Okay children. Now we will move to our next question. Now let us see how HCF and LCM is useful in the second problem. I am erasing all this, okay? So now we will do the second example. Addition. 17 upon 28 plus 11 upon 35. Okay? The first method says, in order to add, let us make the denominators of the fraction equal. So they do the cross multiplication, correct? But we will not do the first method. We will do the second method. The second method tells us to find the LCM of 28 and 35. To find the LCM of 28 and 35. The LCM of 28 and 35 is 7 into 4 into 5, which is equals to 140. Okay children, so we have the LCM of 28 and 35, which is 140. Now let us do the addition. 17 upon 28 plus 11 upon 35 is equals to 17 into 5 upon 28 into 5 plus 11 into 4 upon 35 into 4, which is equals to, if you multiply both of these, the answer is 140, our LCM. So 140. So 17 into 5 is 85 plus 44. 129 upon 40. Therefore children, the addition of 17 upon 28 plus 11 upon 35 is 129 upon 140. It is very simple. If you just remove the LCM, the calculation becomes very simple. Now we will go and see a third example. Third example says, on dividing a certain number by 8, 10, 12, 14, the remainder is always 3. So they have given us numbers 8, 10, 12, 14. The remainder is always 3. Okay. Now we will go ahead and find out the LCM. Over here they have asked us which is the smallest such number. First we will find out the LCM and then we will find out such smallest number. So LCM of 8, 10, 12, 14. If you notice, these are all multiples of 2. 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14. 2 2s are 4, 5, 2, 3s are 6, and the 7 comes down. So these all numbers are divisible by itself only. So we will not write it. Okay. Now LCM of these numbers is 2 into 2 into 2 into 5 into 3 into 7. So we have written all the prime factors, and when we multiply all these prime factors, we get the answer as 840. Okay. So LCM of 8, 10, 12 and 14 is 840. Now we will go ahead and add this LCM with the remainder. Why? Because we need to find the smallest such number. So the number is equals to LCM plus remainder. Okay. So we know what is the remainder and we know what is the LCM. So the LCM is 840 and the remainder is 3. So 843. So whenever you divide 843 by these numbers, the remainder will always be 3. This is how you find out that number, that is this number, if they have given you the divisors. Okay.
Hello children. So today we solved a lot of problems on LCM and HCF. We saw how important it is in our daily life also, correct? So children, you should have a scientific attitude or scientific temper whenever you solve any problems in your life. Because when you have a scientific temper, you tend to ask questions, correct? So children, ask questions because you will find an answer to it. Do not just blindly follow anything. Do not just blindly write anything. Correct? So make sure you increase your scientific tempo. Hence, our today's topic comes to an end. So we have learned about the division method of finding HCF, least common multiple, and the uses of HCF and LCM. I hope you all enjoyed this session. So let us do some recap. The HCF of 120 and 150 is. Now children, come on, tell me fast, what is the HCF of 120 and 150? I hope you all have this answer. It is 30. The product of two-digit number is 765 and their HCF is 3. What is their LCM? Now you have to solve these sums, okay? So 765 and their HCF is 3. So we have learned that the product of two-digit numbers is equal to HCF and LCM. So when we solve this, the answer comes as 255. I have already solved this sum. Which two consecutive even numbers have an LCM of 180? It's very simple. It's 18 and 20. Because 18 into 10 is 180 and 20 into 8 is 20 into 9 is 180. So that is the reason it is 18 and 20. Now the application part, children. Now this is a game of HCF and LCM. Both are different. Okay? It's like a match the following. You have to click on this link, go on to the game and match the pairs. So I hope you play this game. It is a fun game and you will enjoy it. Last but not the least is your homework. Now practice set 12. You have to solve. Find HCF. You have to solve from question number 5 to question number 10. We have already solved 4 questions of the same practice. Now find HCF by division method and reduce to the simplest form. We have done this both. So you have to solve all these three and reduce to its simplest form. Okay. Now the second is the practice set 30. Find LCM, solve from question number 5 to question number 10. So your second question is find the HCF and LCM of below numbers. Verify their product which is equal to the product of given numbers. So the sums are 32, 37, 46, 51 and 15, 60. You need to find the LCM and HCM of both, and you need to check if the product of HCM and LCM is equal to the product of these given numbers. Okay children, so please do your homework. I do not want to see any incomplete homework. Please complete your homework. We have done a lot of problems on HCM, HCF and LCM. I hope you enjoyed today's session. Okay, thank you. Have a beautiful day.